Hello, and welcome to this in-depth tutorial on the GCO method. The GCO method is a variant of the GEG method, which is a highly move-efficient way of solving a 2x2. The version of the method I'll be teaching today has 57 algorithms, and the solutions average around 11 to 13 moves. However, if you were to learn this method, you would want to learn more Alg sets than just this, although it's pretty easy because it's pretty expandable. This method has 3 steps. The first step is to get a specific CO pattern. The CO pattern I will be teaching today is the L case, where you have 2 misoriented corners like this, and the rest of the corners are oriented. These cases generally tend to have pretty good Algs, and also tend to be not too bad to set up to. The next step is to do an algorithm to get you to HTR. And the final step is to finish the cube with half turns. There are a couple problems with this method. The first problem is that number 1, the recognition is very difficult, and number 2, doing half turns at the end of your solve most likely is going to be bad. However, it's not as bad as you would expect. The maximum number of half turns you will ever need to do is 3, and the recognition is difficult, but it is possible to get used to it. With 2x2, you are given a scrambled cube, and your goal is to get to the solved cube. It's very difficult to find an optimal solution from scrambled to solve on its own, so what we do is we use intermediate states. This would look something like a CLL. So you go from scrambled to CLL, and then you do an algorithm to get you to solved. This helps our move count a lot, because it's very easy to find an optimal CLL layer, and then there are just not a lot of CLL cases, so you can memorize optimal algorithms to get you from CLL to solved. The issue here is that this is just quite a few moves. Say your CLL layer takes 4 moves, and then you do a pre-AOF, that's 1 move, and then you do a 9-move ALG, and then you do +1 for AOF, that's 9, 10, 11, 12, 13, 14, 15-move solution. And a 15-move solution is fine, but the average optimal solution for a 2x2 is like 8 or 9 moves. So we can make an improvement here. What if instead of using CLL as an intermediate state, we use HTR as an intermediate state? So what we do is we go from scrambled to HTR to solved. Now, it's a little bit more difficult to find optimal solutions from scramble to HTR because they're on average around 7 moves-ish, guessing. But by learning enough algorithms for scramble to HTR, you can probably get near optimal solutions. There are only around 6,500 possible ways to get from scramble to HTR. So if you learn 500 Algs, that already covers like 8% of all cube states. So finding optimal solutions from scramble to HTR is difficult, but in the grand scheme of things, just by learning enough Algs, you can get there. That was a bit of a tangent. So you go from scramble to HTR and say that takes the optimal solution for scramble to HTR is 8 moves. And then you get 3 half turns at the end. Unlucky. That is an 11-move solution. So after this, we've one-looked this solution and it doesn't work super well. And so we try the second best way to get to HTR, which is, say, a 9-move HTR. And then we get from HTR to solved in 3 moves again. Bummer, unlucky. And now we try the third best way of getting to HTR. Say this is also a 9-mover. And what do you know? This one gives +1. Maybe it's just a U2 AOF. And so that equals a 10-move solution. So by one-looking the best ways to get to HTR from a scramble in sequence, you can very quickly find an optimal or near optimal solution. If you know anything about FMC, this might sound very familiar to you, and that's because this is the exact method that FMC solvers use to solve domino reduction. And this approach of solving to HTR and then to solve over and over again until you find a good skip or like a 4-move finish or something lucky, this has been proven to be the most effective way to find optimal finishes. Here are a few things you need to know how to do before learning this method. The first thing you need to know how to do is how to recognize HTR faces. An HTR face consists of 4 corners that are able to be a face during HTR. So for example, this cube is an HTR, and these 4 corners are an HTR face. If I were to say, take this corner and insert it like this is no longer an HTR face because this face could not exist during HTR. Here's what you need for an HTR face. First, you need all the U face stickers facing up, obviously. And next you need all matching or opposite colors on the side faces, because of course that's how HTR works. Next, you need to not have this pattern with 3 white corners and 1 yellow corner. This is because this pattern cannot exist during HTR, and this pattern with 3 of one color and 1 of the other color can only exist during fake HTR. And lastly, you need it to be sort of symmetrical. So if I have a bar here, then I'm going to have a bar on the back. If I have opposites here, then I'm going to have opposites here. This is in contrast to a fake HTR like this, where you have a bar here and opposites here, and this cannot exist during HTR. The point of this is that you need to be able to identify 4 corners and say whether or not they can make an HTR face. For example, these 4 corners are not an HTR face because number 1, it has a 3 and a 1, and number 2, it has a bar here and opposites here. So this is not an HTR face. If I took this corner and inserted it into this face, this would be an HTR face because you don't have that 3-1 pattern. We got opposites, opposites, and we got bar, bar. This is an HTR face. The next thing you need to know how to do is how to blind trace corners. If you know how to do 3x3 blindfolded, you should already know how to do this. But basically, you trace the corners in a cycle, doing cycle breaks when needed, and you just count how many swaps you do. So here, I would do 1, 2, 3, 4, 5, 6 swaps, and 6 is even, so this is even parity. All right, now that you got the prerequisites out of the way, let's learn the method. The first step of this method is to set up to a specific CO pattern. So what you want to do is you want to take a look at all the white and yellow stickers and try to set them up to this sort of pattern. And of course you can be color neutral with this. So on this scramble, for example, you can take a look at the blue and green stickers, and you can orient a bunch of them by doing this, and then you can set up to that sort of case like this. And now you have this pattern with the blue and green stickers, and that is the first step. The next step is to do an algorithm to get you to HTR. This case looks like this. And the last step is to finish the cube with half turns. The most difficult part of this method is the recognition of the cases. Here's how to do that. Going back to this example, let's make our CO pattern like this. And now let's flip the cube over and hold this case on the bottom. What you want to do is you want to take a look at the pattern on the sides of these corners in the top layer. Specifically, you want to look for matching and opposite colors. And there are 4 different patterns that this can make. The first case looks like this, where all of these side colors are either matching or opposite. This is called the solved case. The second case looks like this, where you have a bar of matching or opposite colors and another bar of matching or opposite colors on the other face. And then we have non-matching colors here. The third case looks like this, where you have 3 sort of matching / opposite corners here, and we have 1 oddball which is not matching or opposite with the rest of the corners. This is called the L case. The final case looks like this, where on every single side there will be no matching corners, no matching or opposite corners. This is called the slashes case. Going back to the example, the next step is to recognize what case it is on the top layer. So here we have a bar of matching / opposite corners here, and a bar of matching / opposite corners here. And these are not matching or opposite, so this is the bars case. I'm going to go over each of these cases individually and tell you how to recognize the case from there. First off, let's look at the L case. The L case looks like this, where you have 3 corners in HTR relative to each other, and one oddball corner which isn't matching with the rest of them. So while holding the L case like this, you're going to take the oddball corner and put it right here in the UFR position. Next, you want to look at these 3 corners. There will be a 4th corner somewhere in the cube, which will make an HTR face with these 3 corners. And that corner is the green, white, orange corner, which is right here. So this case is the DFL case, because the 4th corner that will make an HTR face with these 3 corners is in the DFL position. The last step is to kind of just recognize it like a CLL. What you can do is you can look at this sticker, this sticker, this sticker, and this sticker, and depending on the pattern it makes, you'll know what case it is. In this step, matching stickers and opposite stickers are considered the same thing, so I'm just going to refer to both of these things as matching corners. This case has these 3 corners matching and this corner not matching. So that, combined with the fact that we know that the 4th corner is in DFL, now we know what case it is. So DFL, these 3 matching, this one not matching. Here's the alg. So that's how you recognize the L cases. However, there is one slight catch, and that catch is parity. With this recognition system, half the time you're going to end up with a Y-perm at the end instead of HTR, and to avoid this, you need to trace parity. Here's the way you do that. So this is a completely scrambled cube. This is what the cube will look like when you get it. And you want to trace parity with the blind tracing method. This would be even parity if you traced it. So you just do a blind trace and you trace even. Next, you want to do the setup to the case. So in this case, you can set up to the CO pattern with R, U prime, R prime. Now, you want to take the number of quarter turns you did in that setup and add it to the parity. So we started off with even parity, and we did R, U prime, R prime, which is 3. And so even plus 3 is odd. Now what you want to do is you want to learn an even parity alg and an odd parity alg for each of these cases. So this is the odd parity case. Note that you have to include the pre-AOF in this. So if you have a case like this where you trace odd parity and then you set up to the CO pattern, R, U prime, R prime, plus 3, that's even parity, and then you do a U as pre-AOF, that U is also accounted for in the parity, so that would swap it back to odd. And now you can do the odd parity alg. Also, another note is that half turns count as 2 quarter turns, so half turns don't affect the parity at all. So you can just not account for those when tracing for parity. Here are some examples for recognition with the L case. So here I will hold the L on bottom, and we indeed have the L case. And so let's take the oddball corner and move it into the UFR position. And now let's find the 4th corner that will make an HTR face with these 3 corners. So this can be a little bit tricky, but once you get used to it, it's not all that bad. So I'm just visualizing this DBL corner. And if I inserted it into this spot, that would make an HTR face because this green would match up with this blue and make 2 opposites, and this orange would match up with this orange and make a bar here and there's a bar there, and that's an HTR face. So this is the DBL case. Next, you want to look at these 4 corners. So this is the case where these 2 are matching and these 2 are matching. And lastly, you want to trace parity. So I've already traced parity, and this is an even case. Here's the alg. Here's the last example for case recognition with the L case. We have the L case. Let's take our oddball corner and put it right there in the UFR position. And now let's take these 3 corners and find the 4th corner that will make an HTR face with it. I think it will be this one because the orange is going to match up there, and that's going to work, and the blue's going to match up there, and that's going to work, and the white's going to be there. So that this DBR corner is going to make an HTR face. So we have DBR, parity is odd, and with this case we have these two matching and these two matching. So here's the alg for that case. Next, let's move on to the bar cases. The bar cases look like this, where you have a sort of bar here and a bar on the back. And of course, these could be opposite or matching colors. So what you want to do is you want to take a look at this color, and you want to match up the bar that matches that color. So here's orange, which is opposite of red, and so you want to put the red/orange bar right here on top of it. Next, you want to take these same three corners and find the fourth corner that will make an HTR face with these three corners. This is a little bit more tricky because you have to kind of visualize this corner moving here and then a fourth corner from this bottom layer moving up to this spot. And also another note about this is that the fourth corner in this case could be here. It doesn't have to be in the bottom layer. So when this corner moves here, it's going to make opposites here. And so I think the fourth corner in this case would be, oh yeah, the fourth corner would be this DBR corner, because when this moves, that will match up with that, and that will match up with that, and it's going to be chill. So this corner moves here, and the DBR corner moves there, and that makes an HTR face. Next, you of course want to know the parity, and the parity for this case is even. And lastly, you want to recognize the same way you did for the L case, except in this case, this one is always going to be matching with this one, so that's kind of redundant information. So you only need to look at these three corners. So this is the case where these two corners are matching, and this one is non-matching. So this case is DBR, matching, not matching, and even parity. So the alg for this case is this. You'll notice that the algs for this method are a lot shorter than regular algs, and that's because there's a bunch of different positions that the cube could go into for the alg. You aren't restricted to going into the solved state. You could go from any state to any HTR state, so the algs tend to be pretty short. Here's some more examples for recognition. So here is a case. We have bars. Let's look at this corner. This sticker is orange, so let's match up the orange/red bar. And next, let's trace parity. The parity is odd. Next, let's find the fourth corner that will go with these. It looks like it is this DBL corner, because this corner will move here, this DBL corner will move there, and that will make an HTR face. So we have DBL, and now let's look at these four corners. These two are matching. This one is non-matching. So this is the case. You do Y prime and then you do this. Here's the last example. We have our bars here and we have our L case here. So let's take a look at this sticker. It is white, so let's mash up the white yellow bar right here. And next, let's do a parity trace. The parity is even. Next, let's look at these three corners and find an HTR corner that will go with these. So in this case, I believe this DFR corner will match up to make an HTR face, because this will go there, that will go there, and that will be an HTR face. And let's recognize it looks like all of them are matching. So we have all matching, we have, what was the corner again? DFR. And so here's the alg. Oh, whoops, I messed it up. There it is. There's the alg, U2. Now let's take a look at the case where you have your face on top and all the side colors are either matching or opposite. This can be split into two subsets. The first subset is when you have an HTR face on top like this, and the second subset is when you don't have an HTR face on top like this, because you have 3 and 1. First, let's look at the case where you have the HTR face on top. So what you want to do is you want to look at this corner, just like the last case, and line up a matching bar with it. So here's the green, so you want a green or blue bar above it. So you could do a U prime or a U, it really doesn't matter. You can actually switch between these two and you'll get different sets of half turns at the end. So you can, a little tip, you can do U prime or U, and whichever one gives the better half turns, you can use that one in your solve. So next you want to trace parity. This is going to be even parity. And next you want to look at the pattern of these 4 stickers again. And this one is, these are all matching. So here's the alg for this case. And an R2 finish. Now the other way this can look is if you do not have an HTR face on top, like this. So with this case, what you want to do is you want to take a look at the DFR corner and find which 3 corners will make an HTR face with this corner. So you need to find like 3 corners in this top layer that will match up with this one to make an HTR face. So in fact, in this example, this corner, and this corner would match up with this corner to make an HTR face, because this corner would go there and we would have opposites, and like a bar and a bar, and that would be an HTR face. So you want to take that corner that you want to replace and put it kind of right there on top. And then you want to do the same thing where you trace parity. This is even parity. And then you want to take a look at the corner pattern. In this case, we have all corners matching. And then you want to do the alg. So with this alg, you want to do it from this angle actually. And here's the alg. And now just a half turn finish. The final pattern is called the slashes pattern, and it looks like this. On all 4 faces, you have no matching or opposite colors. So with this case, what you want to do is you want to do a U move so you have even parity. So if you get to a state like this and you have odd parity, you do a U move or a U prime and you'll get even parity. Also, same with the HTR face on top case, you can choose between a U or a U prime move and you will get different half turns afterwards. And so you can just choose whichever gives better half turns. So next you want to, you only need to recognize from here is which corners make the HTR face. You don't need to look at these 4 stickers like with the other cases because it's always going to be the same. So you want to look at 1, 2, 3, these 3 corners, and find the 4th corner that will make an HTR face with these 3 corners. So that 4th corner happens to be this one. If you visualize it, this can move up here and this can move to the back, and that's an HTR face. So there are only 3 cases with the slashes pattern. It's the DFL case, the DBL case, and the DBR case. So this is the DFL case. So what you can do is you can hold it from this angle and do the alg, and you will get half turns at the end, although in this case we didn't. Here are some GCO example solves. So in this scramble, you can make CO with RF R2, and now you have a L case, and you do a U2 as a pre-UF, and now the L. And now just an R2 for a finish. So the full solution, which is a 13 move solution, is this. On to the next one. This scramble has a couple of decent solutions. The first one's a 10 mover and the next one is a 12 mover, but the 12 mover is a little bit more finger trickable, so that's probably the best one to use in a solve. Here's the 10 mover. So what you do is you do R2F to make the CO pattern, and then you do a U2 as a pre-AOF, and now you do the ALG. And now just a U2 finish. The 12 mover is a little bit more finger trickable though. Here it is. So you do U prime F prime R to make the CO pattern, and then U2 as a pre-UF, and now the ALG. And that skips half turns. So that's a 12 mover. So on this scramble, what you can do is you can do an R prime to make the CO pattern, and now you do a U2 as a pre-UF, and now the alg, and now B2, R2 for a finish. On to the next one. On this scramble, you can hold it from this angle, and you can do F prime R2 to make the CO pattern. And now you can do a U as a pre-AOF, and now the L, and now just F2, U2 for a finish. On to the next one. On this scramble, you can hold it from this angle, and then you can do R2F to make the CO pattern, and now a U prime as a pre-AOF, and now the alg, and now just R2, U2 as a finish. The most effective way of implementing this method would probably be to learn all of the corner orientation patterns that are a CLL. This is because if you have a CO pattern like this, where all the misoriented corners are on one face, you can do like a U prime, or a U2, and these give 3 different cases. So the amount of algs you have to learn is effectively cut into a quarter. That is in contrast to a case like this. With this CO pattern, if you do a U, then you get a different case. So you would have to learn 4 times as many algs for a case like this. There's also kind of in between patterns like this CO pattern, where you can do a U2 and still get the same case, which is only 1 symmetry. So that's still more algs, but it's not quite as many. And then after that, there's also like this other pattern. There's like a pinwheel pattern on bottom and like some sort of pattern on top. And this has the same property where you can do U moves, D moves, and you get the same case. Here's a little showcase of that, although I haven't generated algs for all these yet. So here's a random scramble, and as you can see, we already have a pre-made, a pre-made alg that we can do, and it's actually part of the cases that we already know. It's this exact CO pattern, but you know, there's a pre-made alg, like you can find 1 move to an alg, there's 1 move to an alg. I'm sure there's a bunch of ways to get 2 moves to an alg. Like, it's just going to be very, very easy to one-look a bunch of solutions when all the setups are literally just like 1 move or pre-made. And if you one-look like 4 solutions, chances are one of them is going to skip. And that means if you find a skip with a 1 move setup, then you know you found an OO solution. Congratulations. Anyways, that's the GCO method. It's a little bit complicated, but the solutions it finds are quite insane.